Hey guys, this is Coach Lowe, and we are going to talk about 1.3 complex numbers. So I have our real number system over here. The left side is a real number system, and then I have imaginary or complex numbers over here. So I have natural numbers where you learned how to count, and then include the whole numbers with that. And so these are nested boxes, one inside the other. And then the integers include all of these, and then rational numbers include all of those. And remember, rational numbers, any number that could be written as a fraction. Then we have irrational numbers like pi, square root of 3. Those are all in here. We have square root of 2 here. And then we have non-real complex numbers. So these are numbers like a plus bi. They're written in that form, a plus bi, where a and b are numbers. They're not 0. And then also a could be 0. So here we have a and b, and we'll talk about that in just a little bit. And then we have a is 0, so we only have the imaginary part. All right, so that's where we're going to be talking today. So when we talk about complex numbers, the definition of a complex number is I is equal to the square root of -1. We see this when we solve quadratics and we end up with x squared equals -1 or negative something. And then we're like, oh, what do we do with that? Because we can't take the square root of a negative number. It's not real. So that gives us an imaginary number. So this is the definition. I equals the square root of -1. We also know that I squared is -1. So that comes from the square root of -1 times the square root of -1, which would be I times I, which is I squared. So we simplify these radicals first before we do anything else with them. All right, so complex numbers will be a mix, it can be a mix of real and imaginary numbers. So here's my complex number. When it says standard form, that's what that means. We want to write it in a plus bi. Right, so a and b are real numbers. Okay, so a and b will be real numbers. And this is the real number for the real part of the complex number. And b is the real number in the imaginary part. I lets us know where the imaginary part is, right? So when we look at this, if b is 0, then I just have a real number, right? And if b is not 0, then we just have a non-real complex number. So if b is not 0, then we have something like 4 plus 3i. That's a non-real complex number. 4 would be the real part, and 3 is a coefficient for the imaginary part. If a is 0, then I just have a straight imaginary number. It's just purely imaginary. It's a pure imaginary number. So something like 7i. So I have examples of both of those over here in our chart. So that would just be a pure imaginary number. All right, again, this is standard form. So when you see that on your assignment where it says put this number in standard form, that's where we want to get to. So notice there's not a big long fraction. We'll have to split those up when we have a number in the denominator. All right, let's talk about radicals and simplifying those. So if I see the square root of -a, the negative comes out as an imaginary because I can rewrite this as the square root of -1 times a. And we know that the square root of -1 is I, and then we'll simplify whatever this is. So I already know that it's going to look like this before I even start messing around with a. All right, so let's try a couple. So the square root of -5 would be square root of -1 times 5. So I have I times the square root of 5. And I can't break 5 down, so I'm just going to leave that. All right, let's try another one. Square root of -36. So I'm going to take out the negative, so that's I, times the square root of 36. And the square root of 36 is 6, so that's I times 6, or 6i. All right, square root of -28. Square root of -28 is -1 times 28. So I already know there's an I. And then remember, we're going to break the 28 down. So we're going to come over here and start making our factor tree. I like to look for perfect squares first. So 4 times 7. 4 is a perfect square. I could take the square root of 4 and I get 2 2's out of that, right? And you don't even have to keep breaking it down. If you look at 4 and you're like, hey, the square root of 4 is 2, take that thing out. And then the 7 has to stay in. There's no pair for that. I can't take the square root of 7 and get a rational number. So that's it. When I see a negative, I need to be thinking about taking out an I. Okay, just roll one. All right. So let's do some simplifying and adding, subtracting, and multiplying. So we're going to start with multiplying first. All right, so let's multiply the square root of negative 21 times the square root of negative 21. Now I'm going to caution you. We want to simplify these first. Do not multiply them first. So this is going to simplify to I times the square root of 21 times I times the square root of 21. When I multiply these two together, remember when we multiply radicals, we multiply the stuff that's in the front. So I squared, and then square root of 21 multiplied by the square root of 21 is 21. And then we know that I squared by definition is negative 1. So this becomes negative 21. All right, if you have a question on that, star it. We'll talk about it when I see you again. All right, for B, square root of negative 5 times the square root of negative 30. So I'm going to take out the imaginary part. So I times the square root of 5, and I'm taking out an I because this is negative 1 times 5, and I know the square root of negative 1 is I. Same for 30. All right, so I'm going to break down 30 just underneath. So I see that it's 6 times 5 when this should be an I. When I multiply these two together, when I multiply these two guys together, I'm going to multiply the stuff that's underneath. Do you see the pair of 5s? So I'm going to go ahead and take that out. So I have 5, I have I squared, and then the 6 is going to stay in. So I took the 5s out because when I multiply those together, I'm going to end up with 2 of them. And I could take the square root of 25, or 5 squared. I can take the square root of that. All right, I also have I squared because I multiplied these two guys together. So this is going to be negative 5 times the square root of 6. Square root of 6 is 3 times 2. There are no pairs in there, so I'm just going to leave that. All right, let's talk about dividing. Square root of negative 42 over the square root of negative 3. I'm going to simplify first. So I have I times the square root of 42 over I times the square root of 3. My i's are going to cancel. I can put this as, remember that's one of your rules for square roots. I can put them both underneath the radical and reduce. So now 42 divided by 3 is 14. So square root of 14. I break down 14 into 2 times 7. Those are prime numbers. I can't go any farther and there aren't any pairs. So I can just leave that. All right, this one says put this in standard form. So this is what I was talking about just a little bit ago. By the way, all those were in standard form, weren't they? All right, so negative 75 all over 5. So A plus BI is standard form. There weren't any fractions in that. So the first thing I'm going to do is break this into fractions and go ahead and take the I out. All right, so I see for this A, so I'm in A plus BI form. I see for this A part, I can reduce that. So that's going to be 3. And then I know 75 breaks into 25 times 3. I'm thinking quarters. There's 3 quarters in 75. And this is a perfect square. So I have minus 5i times the square root of 3 because the square root of 25 is 5. So there are my pairs that I'm going to take out. And then these are over, oops, that one's not over 5. I already reduced it. But the second one's still over 5, right? We haven't reduced that one yet. So this one's over 5. So now I'm going to reduce that. 3 minus I times the square root of 3. All right, so listen, they both don't have to reduce though. Okay, so one of them may reduce, one of them may not reduce, and that's okay. So you may end up with like the whole number part may be a fraction and the imaginary part is simplified and not a fraction. That's totally fine. All right, let's talk about adding and subtracting. So when I add and subtract the real parts and the imaginary parts. So let me show you one of those. Alright, so 4 minus 5i plus negative 5 plus 8i. Alright, so real parts and imaginary parts. Alright, so the real part that does not have an I with it, I'm going to put those together. Imaginary parts, I'm going to put those together. Alright, so here we go, we're adding. So I have 4 and negative 5. Those are going to go together, plus a negative 5i and an 8i. So I kind of pretend like that I is a variable, even though it's a number. I kind of pretend for a second because I put those together so I can distinguish between the two. So negative 1 plus 3i, and that's in standard form, so I can just leave that. All right, let's try another one. So negative 10 plus 7i minus 5 minus 3i. All right, so I changed to addition. So I push the negative through, and we talked about this last time, that when I have a negative on the outside, it changes the signs of everything on the inside when I distribute it through. So there it is distributed. Notice the sign changes. Then I'm going to add the real parts, and then I'm going to put together the imaginary parts. All right, so the real parts together, I have negative 10 and negative 5, which would be negative 15. And then I have a positive 7i and a positive 3i, and that would be positive 10i. All right, so that's adding real and imaginary, adding and subtracting complex numbers. All right, so let's talk about multiplying, and then we'll finish up when I see you again. So multiplying. When I multiply complex numbers, I use the distributive property. And some things that I want to remember are I is the square root of negative 1. And I squared is negative 1. So when I see I squared, I can replace it with negative 1. All right, so let's multiply. So I'm going to distribute 5 times 2 and then 5 times negative 7i. So I multiply the numbers. Make sure you write the I down. I go inside. I'm going to distribute negative 3i. So distributing negative 3i is positive 6i. Distribute the 3i to the negative 7i. Negative 21i squared. There's that I squared. I'm going to replace I squared with negative 1. So now I have 10. I'm going to go ahead and put these guys together. Minus 29i plus 21, because negative 21 multiplied by negative 1 changes the sign, and now it's positive. So 31 minus 29i, and that is in standard form. All right, so there's the first one. Here's the second one. All right, so 4 minus 5i squared. I need to make sure I rewrite that. 4 minus 5i times 4 minus 5i. And then I do the distributive property. Please, 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 please be careful about that. All right, let's talk about dividing. So dividing 5 minus 5i divided by 3 plus 3i. I multiply by the conjugate. The conjugate means, because I want to get the I off the bottom, I can't have a square root in the denominator. I'm going to write exactly the same thing down and multiply top and bottom. So I have distributive property on the top. So I'm going to distribute the 5, 15 minus 5i. I'm going to distribute the negative 5i, negative 15i plus 5i squared. So there's that negative 1 coming into play, over 9, I'm going to distribute the 3, 9 minus 3i, and I'm going to distribute the I plus 3i minus I squared. So now I have some things going on. Those are gone. This is going to be positive 1. This is going to be a negative 1. So now I can clean up. So I have 15 minus 5. Those signs are going to change. So that's going to be 10 minus 20i all over 10. And then I'm going to break and reduce. So 10 divided by 10 is 1. And negative 20i divided by 10 is 2i. So I broke that into 10 over 10 minus 20i over 10, and then simplified. All right, that's it, guys. Write down your questions, and I'll see you soon. Bye, guys.